Okay, we're going to cover how to do Stoich problems with volume, with liters, and with particles like the mole. So 6.02 times 10 to the 23rd. Okay, so the first problem we're going to do is using the conversion for mole and liters. 1 mole is equal to 22.4 liters. Okay, so again, you need a balanced equation. And here, 5.5 moles of C5H12. That's your number that you're given. And you're trying to figure out what volume, meaning the liters, of carbon dioxide you're going to make. So that's your unknown. Okay, so we're going to set up our T-chart. And to see this one, we're going to be given moles, and we're going to liters of our new substance, carbon dioxide. So we are given moles, and we're going to go to liters. So this is going to be two steps using the mole to mole ratio to going to our carbon dioxide moles. And then we're going to convert the carbon dioxide moles into liters of mole. So these are going to be the two steps conversion factors in our T-chart. So we're going to cancel out the mole of C5H12 and put that on the bottom. So first let's write the given. So 5.5 mole C5H12. And we are going to put mole C5H12 on the bottom. Again, the question mark here is prompting you to look at the balanced equation, the coefficients, the big numbers. Okay, so C5H12, there's a 1 there, so we have 1 mole of it. And for every 1 mole C5H12, we're going to convert to mole of carbon dioxide, which we see here in the reaction, we're going to produce 5 moles of carbon dioxide. Okay, so now we're in moles of CO2. We want to get to liters of CO2. Okay, so we're going to put the 1 mole on the bottom of CO2, carbon dioxide, and 22.4 liters of carbon dioxide on top. So we're going to cancel out mole CO2, and we know for every 1 mole of carbon dioxide, that's equivalent or equal to 2.4 liters carbon dioxide. Cancels out. We're in liters of carbon dioxide, which is what we wanted. So again, we're going to multiply the top numbers. So 5.5 times 5 times 22.4, enter. Our denominator is just 1, so this is our answer right here. So if we divide it by 1, it would be 616 as well. So 616 liters of carbon dioxide. Okay, so that's a volume type of problem. Let's see one where we're using particles or atoms or molecules. For every 1 mole of a substance, that would be equal to 6.02 times 10, that's to the 23rd, atoms, particles, or molecules. So again, we need a balanced equation. Okay, and it says how many atoms of magnesium, so that's our unknown, we don't have a number there, would be in the presence of 2.5 moles of oxygen. So that's your given. So that's going to go in the top left. So we were given 2.5 moles of oxygen, and we're trying to figure out atoms. So let's put atoms, magnesium at the end so we know where we're going. Okay, so we are starting at moles and going to atoms of a new substance. So we were given moles. And here, our unknown, we are going to atoms. So our first step is the mole ratio step, going from, oxygen to magnesium, and then we're going to convert the 1 mole magnesium to the atoms of it. Okay, so mole of O2 on top, we want to get rid of it and put mole of O2 on the bottom. This is the step, mole A is your starting substance, like oxygen, O2. So now we're going to go to mole, what we're trying to get to, which in this case is magnesium. So mole of magnesium. So I'm going to look at the balanced equation. I see for every 1 mole of oxygen, I have 2 moles of magnesium. Okay. Here, moles of magnesium doesn't match atoms yet, so we're going to do one more conversion, and we're going to use the conversion factor for every 1 mole of a substance. You have 6.02 times 10 to the 23rd. So for every 1 mole of magnesium, we put mole on the bottom to cancel out the 1 on the top. We have 6.02 times 10 to the 23rd atoms of magnesium. Moles cancel out. Here we match, so we're going to multiply our top numbers. 2.5 times 2 times, all right, so let's look at that, 6.02. We have to use the second button and then the EE function. That's the times 10 to part, okay? And then we're going to write 23. Enter. And then again, we only have 1s in the denominator, so that is your answer. 3.01 times 10 to the 24th.